Here you see the pinout for the Texas Instrument TMS27C64, which is a typical CMOS EPROM IC. This chip is referred to as a 64K EPROM since it is capable of storing 8,192 8-bit words, which is approximately 64,000 bits. The TMS27C64 has 13 address inputs labeled A0 through A12, 8 data input outputs labeled Q1 through Q8, and 3 control inputs labeled not PGM for program, not G for output enable, and not E for chip enable. This IC also contains 2 power supply pins. VCC is plus 5 volts, and VPP is plus 5 volts for normal read operations and 12.5 volts for programming operations. Reading data from the TMS27C64 is a very simple process. First, the program input, not PGM, is brought high and plus 5 volts is placed at the power supply pin, VPP. Next, address inputs A0 through A12 are used to select the desired address. Then the chip enable input, not E, and the output enable input, not G, are brought low. After a short delay, the data stored at the selected address will be displayed at outputs Q1 through Q8. Programming this EPROM is also a very simple process, but keep in mind, programming can only change 1s to 0s. It cannot change 0s to 1s. Therefore, before the EPROM can be programmed, its memory addresses must all be changed to 1s by exposing the EPROM's transparent window to a concentrated ultraviolet energy. The first step in programming this IC is to select the desired address to which the data will be placed. Remember, the address lines are A0 through A12. Next, the desired data to be programmed at this address is placed at inputs Q1 through Q8. As you recall, inputs Q1 through Q8 are used for both input and output operations. Next, the power supply pin, VPP, is increased to its programming voltage of plus 12.5 volts. Then the chip enable input, not E, is brought low. Next, the program input pin, not PGM, is pulsed low for approximately 50 milliseconds. To verify that the byte has been programmed, simply bring the output enable input, not G, low, and the programmed data should appear on Q1 through Q8 for the programmed address. A word of caution. Not all EPROMs are erasable. There are one-time programmable EPROMs available on the market. These use EPROM technology but have no windows and therefore are not erasable. We will now pause for a short review of the material most recently discussed. The typical EPROM can be written to and erased from several hundred times and still maintain its reliability. The EPROM memory cell contains a floating gate which is used to store a 0 when charged and a 1 when not charged. The EPROM memory cell is programmed by forcing a high energy state through the floating gate. The gate will retain this charge even after the programming voltage has been removed. Most EPROMs contain a transparent window which is used to permit ultraviolet energy into the memory section. This ultraviolet energy will erase the data contained within the IC. An opaque label is generally placed on the transparent window of the programmed EPROM to prevent outside sources of ultraviolet energy from entering the memory section of the IC and causing errors in the data. Once a bit has been programmed to a 0, it cannot be changed to a 1 without erasing the entire IC and starting over. This concludes review number 3. We will now examine the electrically erasable programmable read-only memory device. The EEPROM, or as just mentioned, electrically erasable programmable read-only memory device, is a popular alternative to the EEPROM just discussed. As you recall, the major disadvantage to the EEPROM was its inability to be reprogrammed quickly. This was due to the fact that the EEPROM had to be subjected to a concentrated ultraviolet light source for a period of 15 to 30 minutes before the data was erased. In regard to reprogramming the EEPROM, it was an all or nothing process. You either erased all of the data or none at all. The EEPROM, on the other hand, can be erased and reprogrammed in a matter of microseconds. And an equally important advantage is the fact that the EEPROM can erase 1 byte at a time instead of the all or nothing approach. Here you see a pinout for the Texas Instruments TMS27C64, which is a CMOS 64K EEPROM. This memory device uses a floating gate technology similar to that used by an EEPROM. This EEPROM is capable of storing 8,192 bytes of information. The TMS27C64 has 13 address inputs labeled A0 through A12. It also has 8 data input-output pins labeled DQ0 through DQ7. The control pins on this device are not W for write, not G for the output enable, not E for the chip enable, and R, not B for the ready busy signal. Reading information from the EEPROM is a simple process. First, the address is selected using the address inputs A0 through A12. Next, the write input, not W, is brought high, while the output enable, not G, and the chip select, not E, are brought low. After a short delay, the information placed at the selected address will appear at output pins DQ0 through DQ7. Writing to the EEPROM is also a very simple process. Writing a single byte can take as long as 10 milliseconds, which is a considerable length of time in the microprocessor world. However, once the write cycle is initiated, the EEPROM will take over and complete the process on its own. This allows the microprocessor time to perform other tasks. The EEPROM cannot be read or written to until the write operation is complete. To program the EEPROM, you must first select the desired address to which the information is to be placed using address inputs A0 through A12. Next, the chip enable input, not E, and the write input, not W, are brought low. Also at the same time, the output enable pin, not G, is brought high. Third, the data to be stored is placed at the input-output pins DQ0 through DQ7. Next, the chip enable and write pins are taken high. When this occurs, the ready busy pin labeled R not B is brought low. When the write operation is completed, the ready busy control pin goes high to indicate the IC is no longer busy and can now be read or written to. The typical EEPROM can be erased and written to thousands of times and still maintain its reliability. EEPROMs are available in 8K, 64K, and 256K capacities. We will now pause for a short review of an electrically erasable, programmable, read-only memory device. The EEPROM is erased electrically and does not require the use of ultraviolet energy. The EEPROM can erase and overwrite portions of its memory. It does not require the entire memory to be erased first. EEPROMs use a floating gate technology which is very similar to that used by the EPROM device. The EEPROM will generate its own programming voltages within the IC. This allows the EEPROM to be powered from a single 5-volt power source. EEPROMs can be erased and written to several thousand times without losing reliability. EEPROMs are commonly available in 8K, 64K, and 256K capacities. This concludes review number 4. Now we are going to examine RAM technology.